Lesson 2-3, reflections on our state standard 8G1, where we can see again in our thing, we want to look at reflections. It's one of our vocab and one of our skills. When we talk about a reflection, that's one of those transformations, a thing that changes. It's one of our changes. And a transformation is where it's reflected, a reflection, or rather flipped. And importantly today, we're going to have a line of reflection. Usually the x-axis. Remember, the x-axis is the one that goes horizontal. That's our x-axis. Or the y-axis, which will be the one going vertically, going up and down. X-axis is your horizontal axis, like the horizon where the sun sets. And the y-axis is what goes up and down. Be very careful that we reflect it in the right one. In front of you, you can see all three examples. What I'm going to look at is I'm going to look at them one at a time. Again, today we're not looking at a translation. A translation is where I slid this down, and it's the exact same. We want to know if I took that heart and folded it over the line, would it be flipped down here and be the opposite? Well, when I drag it like this, we can see it's not. So again, when we talk about it, it's not a reflection or not reflected. And then if you had to, you could justify your response. How or why? Why is it? It's not a reflection. What is it? It's a translation. It's a translation because it just slid straight down. It's a translation. That's what you're looking at. We move to the next one. Again, you can see all of them. Now, if we could take it right here on this line and we could fold it over that line, would it flip down onto the other side? One way to look at it again, is it exactly the same if I slide it down? No. Is it flipped? Is it rotated? Is it flipped or is it reflected over this line? So is it facing up on the top here? And then on the bottom facing down? Yes, it is. So then this one would be yes. Is it a reflection or not? Yes, it is a reflection. Why? It's been flipped over the line. Or it's been reflected over the line of reflection. Many different ways to say it. And that last one. Is it a reflection? Is it completely flipped? Now again, flipped just meaning reflected over. So if I were able to put a mirror right here, when we're looking at it, we're going to talk about, is this the same distance here away? Is this the same distance here away? Is that the same distance and this the same distance? No. This one is not a reflection. In fact, this one, when you remove all those lines, you can see that it's not just reflected, but there seems to be a twist or turn in it. So we're going to talk about that one later. This one is a rotation. So if you had to justify your response, you could say no. It's a rotation, and that's that. That's our part where we're talking about identifying. So we want to be able to verify or be able to see when there is a reflection and what they look like. As well as part of our skills here, you can see, says to actually transform lines or angles, to transform shapes. So we must actually do some reflecting ourselves with graphs and graph paper. One thing to note before we move on, as you're looking at these on the top, if you need to, draw a little squiggly line between them or a line so you can see that there's a difference. When we talk about reflection in the x-axis, again, the x-axis is the horizontal axis. When you reflect a point in that, notice there's a minor change in here, and it's right there. The y is opposite, because if the point was up here on top where it's positive, reflecting it in the x-axis, it's going to be down here in the bottom where it is now negative. Same thing here, very quickly, if you're not asked to show your work, when it says to reflect something in the y-axis, remember the y-axis goes up and down at point 0. When you reflect a point on the y-axis, notice if it starts over here on the right where it's positive, once we reflect it over, that's the change that we see here in the y-axis. Only thing that's changed is the x value is now the opposite. So if it started positive, Now it's negative. Or the opposite. If it started negative, once you flip it in the y-axis, then it is positive. The vertices of parallelogram are -1, -1 at A, B2, -1, C4, -3, and D1, -3. Draw the figure and its reflection. What are the coordinates of the image? Step 1 says to draw the figure. So we're going to draw that on in. A at -1, -1. B, go ahead and label that, at 2, -1. C at 4, -3. So over 1, 2, 3, 4, down 1, 2, 3. Put a letter C there. And D at 1, -3. Again, if you'd like to have bigger dots on that, you can do that as well. So they're nice in circles. And then just connect those guys together. Wrote my B in the wrong spot. Don't forget to label all those points. Now that we've drawn it, boom, now we can reflect it. Careful, read very carefully. Where are we doing it? For us in class, we're going to stay specifically on the X or Y axis. So here's that X axis. Now you don't need to draw it in, but I'm going to. So in your notes, please do so. I'm going to draw a line. I'm going to use my highlighter in the notes and draw a line right there. That's the x-axis. Please do that in your notes. You can just use a pencil if you want to switch to a highlighter or a colored pen. You can do that quick. But draw a line on that x-axis. Then from there, we need to reflect it over the x-axis, which means if A is 1 down or 1 away from the x-axis, A prime in the new image is going to be 1 above. We're just going to flip it or reflect it over that line. Again, B, since it's down 1, reflect it over and put it up 1. There's B prime. C is down 1, 2, 3, so reflect it, flip it over this line and go up 1, 2, 3. Put a dot there, label it C prime, and then D prime again. If it's down 3, we're going to go up 1, 2, 3. And label it D prime. You have now reflected that pre-image, parallelogram ABCD, over the x-axis to create that image. Now you have done reflected over the x-axis. Do note, though, it does continue on, and it does say to name or give the coordinates of the image. So we must do that. Again, on IXL, you must be very careful as we talk about A prime, B prime, C prime, and D prime. If even one of these numbers is off, IXL counts the whole problem wrong. Mr. Walls, myself, will count just a couple, take partial points away. So not the whole thing wrong, but we do need to be very careful. So count carefully. Make sure that you see that it's at -1. -1 for A, B prime at 3, that is 2, 1. Again, had I put the 3, the whole problem would have been wrong on IXL. On an assignment or an assessment, a quiz or test in Mr. Walls' class, Mr. Walls, myself, would have taken partial points off for having that 3 there, and that is not right. C, count carefully, is over at 4, +3, and D at 1, +3, and because it did ask for us to have the coordinates as well, all of these are needed. So you're going to need that grid paper over here and have that part of your graph, part of your assignment, as well as all of these points somewhere. One last one. The vertices of a triangle are A1, -2, B4, 1, C1, 4. Notice again, draw the figure, reflect it over the y-axis, and then it says, what are the coordinates? A couple of things we have to do. Starting at the top, draw the figure. So there we go. A at 1, -2. A at 1, -2. Again, if you want to put a better dot on that, you can do that as well. And that's A, so label that. And then B up at 4, +1, 1, 2, 3, 4, +1. Be very careful, just like on IXL. If you have that off just ever so slightly on one of these, IXL will count the whole graph wrong. Mr. Walls' class, I'll just take partial points off, and I'll explain that in class better about the partial points, or you can ask me in person about that. And then lastly, C at 1, 4. 1, 2, 3, 4, right there. Label that C, or again, if you want to put a big dot on that, you can. And then freehand or straight edge, all allowed. Listen to your teacher, what they tell you to do for that connecting of the figure. Then reflect it over the y-axis. Once again, you don't need to do this, but because it's our notes, please trace over this y-axis. I'm going to use a highlighter. You may use a pen. You may use your pencil just to kind of darken that or thicken that line just ever so slightly, so that way we can see that we're reflecting it over the y-axis. So whatever point you want to start with, I'm going to start on top here with C. Since C is 1 to the right, put the new dot, the image, C prime, 1 to the left. B, count carefully, 1, 2, 3, 4 over to the right, reflect it, flip it over that y-axis, 1, 2, 3, 4 spots. For your B prime, again, if you want to make better dots, you can do that as well. And then A prime just over, A prime just over 1. Put a dot there and then connect it because it said draw the figure and its reflection. So this is the reflection. No, you don't have to put the dots on there as you count. I'm just doing that for notes in class and here on this video so you can see it. There you have drawn the figure and its reflection. You've got the image drawn, but again, it says what are the coordinates? So make sure you list those. A prime is at -1, -1. B prime, make sure that apostrophe is there, is at -4, +1, and C prime is at -1, +4. Notice we had that little shorthand a while ago when we reflected things over the y-axis. Notice what happened to the x values when we take a look at them here. It started as a +1 way up here on the top. Now it's a -1. B was up at 4, 1. Now it's at -4, 1. C was at 1, 4. And now it's at -1. The only thing that changed was the x value has become the opposite. If it doesn't say draw, if it doesn't say draw the image or reflection, if it just says give the coordinates, I don't need to see any of this. You can jump straight to your final answer here with the coordinates. You are always welcome, though, to grab your graph paper and draw in the reflection. But if you see that little flip, you can do that, especially on a standardized test. It saves time. Jumping back one, we see the same thing happened here when we reflected over the x-axis. Notice we started at -1, -1. So when we were flipped it over or reflected over the x-axis, it should be at -1, +1. Uh-oh, Mr. Walls made a mistake. I've told you very often that I will make mistakes in class and out of class. So when we look at that, that's one thing you're going to see, that actually needs to be a +1. Make it a +1. Because when we look at B, we're at 2, -1, flipping it over the x-axis. It's now at the opposite, a +1. C, the y value was at -3. The opposite is a +3, and the same with D. Flipping it over the x-axis, that changes it from a -3 to a positive. That's what this was talking about right here when we look at this quick little shorthand. So if these letters weren't making sense, perhaps now they make a little more sense that we've seen some examples. If not, don't worry. You don't have to have this thing memorized. Graph it, reflect it, and then find the coordinates of the image. If it doesn't tell you to graph it, then you don't have to. But if you need to get the coordinates, then graph it. Because what we're looking at is, today, we're looking at reflecting, one of our skills that we need to do to be able to do the standard, which the standard itself says we need to identify the properties of reflections, as well as be able to do the reflections. That is your I can today. that you can identify what is or is not a reflection, but then you can go and actually do that. You can reflect figures in the x-axis or y-axis. Now, those aren't the only lines of reflection, but for today, for almost the most part, everything you see is going to be in those or over those lines of reflection.